Hello everyone. Today we are going to discuss about a problem which is a square root of a number. So the number, the problem number it is 69 in lead 4 as we can see here. See, they will give, if you see the description of this problem, they will give non-negative integer. Then we need to return the square root of x, that to round it down to the nearest integer. The returned integer should be non-negative as well. So we must not use, see, they have mentioned that clearly, that is, we must not use any built-in functions, that is exponent functions or operator, math operator like math dot square we should not use like that. If we see example 1, input is 4 and output is 2. Why? Because the square root of 4 is 2, right? So example 2, input is 8, output is 2. Why? Since the 8 is not a perfect square here, we take, so we may get some decimal values, but we should return only what? Only integer value. So this is a problem, guys. We can use binary search here, guys. Okay, let's have a look on binary search here. See, actually binary search algorithm contains lower boundary and upper boundary and the mid value. How can you find the mid value? Lower plus upper by 2, isn't it? Yes. How, why is it called binary? Means when we find the middle value, if it is not equal to target, then we should go left side or some right side. Okay, that is going to be decided on based on value of middle. Okay, middle value, right? So when we decide that, then it is going to divide it by 2 offs. Okay, so that's why the binary came. So binary means 2, right? So that's why we see here. See, they have given a key value that 23. Here is a 23. So first of all, find the middle value, that is 0 plus 9. Here the mid value equal to 4. 0 plus 9 by 2, it is nothing but 4. We should take integer value only 16. 16 is less than this key, right? We should go then right side. So we should update the lower boundary value, which is lower. Okay. Then if it is lesser means we should go left side. Okay, if it is greater, I mean the mid value is greater than that. Here the lower boundary and mid value became same. We got the answer. Let's implement this here, guys. So before that, let's take an example. Yeah, let's take, for example, x equal to 4. Then how the lower boundary may be 1. Why? Because the square root of x means it lies between 1 and that number, right? See, this is the lower value then. Then it is the upper value. Obviously, mid value how much? 2 only, right? How? We have that formula. Mid equal to L plus U minus L floor 2. Okay, that equal to 2 here. Yeah. So in this case, see, square root means that should be equal that that number into with itself. It should be equal to x. Then only we can say that the square root of it is a square root of number x. Here 2 into 2. 2 into 2. It is 4. So we got the answer in this one step only in this case. But if we see, if x equal to some 9, if x equal to some 9, let's take the possible values here up to this. Okay, let's take this is L value, then the middle value, obviously it is an odd number, obviously the middle value becomes 5 only. Then if you take the lower bound, upper boundary is highest one. Okay, let's see here, mid into mid, that is 5 into 5 equal to how much? 25, which is lesser than that 9, right? So that means what? That is in left side only. So we should update that upper boundary, that is mid minus 1, that equal to 5 minus 1, that is 4. Now see, guys. Now see. Yeah. That is L value as we discussed. And now it is U value, upper boundary. Obviously, 2 will be the mid value. Okay. 2 will be the mid value. Right? Now see, 2 into 2 is 4, which is less than 9. Isn't it, guys? Then we should update. We should go right side. We should go right side, right? We should go right side. We should go here. It is. We should go right side. So we should update that L value equal to mid plus 1. Okay. That equal to 2 plus 1. That is 3. Now here we go. That is L value 3 and upper value U mean 4. Here mid value also 3 only. Why 3 plus 4 by 2? It is 3 only. So here we got now 3 into 3 equal to 9. Isn't it, guys? 3 into 3 equal to 9. So got now. Let's calculate the time complexity. See, guys, it is going to divide by 2 halves, right? So that's why you can say that n by 2 power k. So this is a scenario. Let's take, yeah, that is going to be written as 2 power k equal to n. Okay, 2 power k equal to n. 2 power k equal to n. Let's take base value, I mean logarithm with base 2. Log 2n equal to log 2 base 2 it is, and 2 power. Here the log 2, here it will be cancelled and the k will be there, that is k equal to log n. Got it or not? So the time complexity equal to order of 4 log n for the binary search. So this is about this, guys. Yeah. Here we go now. Now implement this, guys. So L equal to, as I said, L equal to 1 and U equal to how much? And upper boundary becomes, that is X only, right? Then we keep on traveling, that is L less than or equal to upper boundary. And then we should find that middle value, that is L plus U minus L and floor 2. Okay. And we should check that mid into mid equal to equal to X. Then we can return here only, that is int of mid. Then we should check the other condition. If mid into mid is less than X, then we should update L lower boundary, that is mid plus 1. And we should assign to a variable here mid, answer equal to mid. The other condition, last one. If it is greater means we should update the upper boundary value, that is U equal to mid minus 1. Okay. Now simply return int of mid. If it is, guys, if the X equal to 2, if X equals 0 or 1 means, see, square root of 0, which, how much 0? Square root of 1, how much? 1. So if simply we can say that if X equal to, which is less than 2, then we can return here only, that is return X. That number only we can return, right? Let's run this code, guys. We got some wrong answer. See, we should use here, should return the variable, right? Yeah, passed or not. Yeah, passed. Let's submit this code. I got it. So this is